Hi, welcome back to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 12 physics contest called the Sir Isaac Newton Contest, and this is a question that involves both energy and momentum. So in this question, we have two Olympic figure skaters, one with respective mass and velocity and another one, which are heading towards each other and then collide mid-air. When they collide, they hold on to each other and therefore end up with a common velocity and no rotation. You need to calculate the percentage of total kinetic energy lost by the pair during the collision. Give it a try and I'll be right back with the solution. Alright, so to figure out the total kinetic energy lost, you need to know how much energy you had before the collision and how much energy you have after the collision. Now, after the collision, when these two collide, they're going to be together moving off in some direction, most likely in this first quadrant. However, we can't figure out what that kinetic energy is if we don't know the velocity. Now, since they're holding on to each other, we know the mass is the sum of their masses. That mass is going to be 55 plus 45, so we have 100 kilograms. But our velocity, let's call it v prime, is something we don't know. So before we can figure out how much kinetic energy is lost, we need to find this velocity of the two of them together after their collision. To do that, we're going to use conservation of momentum. And because this is a two-dimensional collision, we're going to do it in components, both our x component and our y component. So let's start in our x component. So we'll do total momentum in x must equal total momentum after the collision in x, which we'll call prime. So before the collision, let's call this figure skater 1 and this figure skater 2. Before the collision, we have a component of this momentum. So this says 30 degrees south of east. So if we're to draw components like so, this would be 30 degrees. And so the only component we have is this component, which we would say is mass times velocity, which is 55, times 14, so that's our momentum, multiplied by the cos of 30. And that is going to be equal to this horizontal component for after the collision, which is the sum of their masses, which would be 100, multiplied by that velocity in x prime. So if we rearrange this, we can solve for what that vx prime would be. And it turns out that it is 6.67 meters per second. And that would be east. Right, so we're going to have to do the same thing, but we're going to have to look at our y components now. So all the momentum in y before the collision must equal all the momentum in y after the collision. So before the collision, we have skater 2, which is traveling north. That'll be our positive direction. So we have their mass. Remember, this is conservation of momentum, so we need mass times velocity. So we have 45 times their velocity, 21. And then we're going to subtract because this component is down. Their mass is 55 times their velocity, which is this component, which would be 14 times the sine of 30. And that is going to equal this momentum right here after the collision, which we will have as mass times velocity, so 100. Times that vertical velocity vy prime. And we can rearrange this equation to solve for vy prime, which turns out to be 5.60 meters per second, and that would be north. Alright, now once we know what these components are, and we know it's a right angle triangle, we can use Pythagorean theorem to solve for v prime. Now you can also solve for the angle, but in this question we don't need to because energies will be a scalar quantity, and so we don't need to know the direction to figure out the total kinetic energy loss. So we'll just use Pythagorean theorem, where v prime will be equal to the square root of our x component, 6.67 meters per second squared, plus our y component, 5.60 meters per second squared, and we get v prime to be 8.71 meters per second. So now that we've calculated the velocity of the two skaters after the collision, we can go ahead and calculate the kinetic energy of the two skaters before the collision and the kinetic energy of the two skaters after the collision to see how they compare and how much we've lost. So before the collision, our kinetic energy is therefore equal to 1/2 the mass of our first skater, which is 55 kilograms, times their velocity squared. Remember, we don't care about direction. Kinetic energy is a scalar quantity, so that's just 14 squared, plus 1/2 our second skater's mass, which is 45 kilograms, times by their velocity squared, so 21 meters per second squared. And that gives us a total of 1.53 times 10 to the 4 joules. And now we can go ahead and calculate the kinetic energy after the collision. So that's 1/2. Now their combined masses, which is 100, and their velocity together, which is 8.71 meters per second squared. And that gives us a kinetic energy of 3.79 times 10 to the 3 joules. Alright, so if you subtract these two kinetic energies, we will see the kinetic energy that we've lost, which is equal to the difference of these two kinetic energies, is 1.15 times 10 to the 4 joules. And divide that by what we originally had, which is 1.53 times 10 to the 4 joules, times by 100%, and we get a kinetic energy loss of 75%. Our answer is A.